Okay, so hi everyone, welcome to this video, and in this video we'll be talking about magnitude of a vector. Okay, so I'll be fast as I can. Now, the magnitude of a vector is simply the size. Oh, that is so straightforward and simple. The size of the vector or the length of the vector, that is the magnitude of the vector. Now, what that means is that we are only considering the size. So if we have a vector, let's represent that with an arrow, because that's I think a very pictorial way of giving, or the simple way we can show this. So if we have a vector, this is a vector, it has a magnitude. The magnitude here just means the size. So this is how long this thing is. Okay, so this is how long it is. So this length is the size, and that size is the magnitude of the vector. Now note that when we say magnitude of a vector, we are not considering the direction, we are just talking about the size. So for the fact that so the magnitude of a vector is its size or length, that is, we consider its size without its direction. And for us to consider for the fact that we consider only the size, which is the only the size without the direction, this thing or this idea is the same as that of a scalar, because a scalar quantity or scalar quantities are those quantities that have magnitude but no direction. So for us to consider and say the magnitude of a vector is its size, we are just saying that that implies that the magnitude of a vector is that scalar which is numerically equal to the vector. So if we say here is a scalar quantity, okay, so if we say we have one scalar here, this is a scalar quantity and this is a vector quantity. Now for the scalar quantity, we just talk about the size, no direction. For the vector quantity, we talk about size, which is magnitude, size and direction. So if you want to know the magnitude of the vector, we just look at only the size, and looking at just the size, it is the same definition as the scalar. So it really makes sense to say that the magnitude of a vector is a scalar that has the same or equal numerical value as the vector. Okay, now to express this mathematically, because we have to, so that we can manipulate and do operations with vectors. So to express this, excuse me, 9 o'clock, excuse me, let me take out this nice light. Yeah, comes up automatically. Okay, now to express this mathematically, we use this sign for it. It's expressed as this, which is modulus. Let's say vector A, we use this sign for it, okay, and then we say it's equal. Now before I write anything or the next thing, the vector, or magnitude of a vector, or just a vector, has components. If a vector is moving in space, if a vector is moving in two-dimensional space, so x and y, if a vector is moving in two-dimensional space, x and y, that vector will have two-dimensional space. If a vector is moving in two-dimensional space, that vector will have some part of it, let's say it's moving like this. So this vector will have some part of it some x components, and it also has some y components. So this idea of having x and y components has already given us let's say hints to what we're supposed to do, and that has been given to us already by Pythagoras, which is to say this here, this part here is our magnitude, okay, or is our vector. So just the length is the magnitude. So, and remember Pythagoras theorem, this in Pythagoras theorem is C, and this part here is the same as this part. Let's say this is B and this is the A. Okay, so according to Pythagoras theorem, A square plus B square equals C square. Okay, so we can express this as saying this will be our C square equals A square plus B square, and of course making C subject formula, we'll have this B square. Yeah, so this is for our Pythagoras. This is my drawing, man, but I believe what that's what I'm trying to do as part of the drawing, eh? So let me give you a better drawing. Yeah, a better drawing. Okay, so this is for x component and this is for y component, and this is our vector here, vector here. Now y, hey, what was that? So y component and then x component. Okay, so this is the C part. Now of course this is same as this. Bam, bam, bam. Okay, same y here, opposite sides bar, the same thing. Now since we've gotten this for C, it simply means this C is the same as this in magnitude. That means we are going to have our the magnitude of the vector A as x plus y squared, and we have this. But this is not really accurate, okay? It's still accurate though, but we'll put it this way. We'll this way, take this out by saying this is A x. That means the components of vector A in the x direction, of course, squared, plus components of vector A in the y direction squared. So this is our formula for the vector. Okay, this is our formula for the magnitude of a vector. Right, yeah, that's it. That's it. Now this is for 2 dimensions, okay, or 2-dimensional space plane. Okay, now if we are talking about 3 dimension, very easy. This same expression, but we are going to add the 3rd dimension. That's just to add, let me copy this whole thing, excuse me. So what will just happen is we are going to have a 3rd component, which will now be in the xy. Okay, so the 3rd one will just be this same thing, but we'll have plus A in this direction squared, and this guy extended. That's just for 3 dimensions. Okay, so what of just 1 dimension? That means, but wait, in 3 dimensions we mean we have a component of A in x direction, we have it in y direction, and we have it in the third direction or dimension. So we will now take all together sum them, square root of each one, square of each one, and then take the square root of that answer. But if we have the vector A moving in one dimension, it simply means the magnitude of that vector is the absolute value of that particular dimension, since we are moving in one dimension. That means for a one-dimensional vector, one dimension really, we just have magnitude of A. We just have magnitude of A. What's this now? Excuse me. A equals A. Okay. If it's X or just whatever direction, it should just be like that. Okay. Since it's just one dimension, we just have it that. Okay. So that's that. Then I think that's all for this video. So yeah, if you have any question, just leave it in the comment section, and then of course share the video, like, subscribe, and then yeah, so yeah, see you in the next video. And this will be all for this video. In the next video we'll talk about the unit vector. Okay, what's the unit vector? And the idea for unit vector is the direction, because in this video we talked about just the size. So the next video we'll talk about the direction, how to figure out how to get direction of a vector. Thanks for watching, and see you in the next video.